Friends, welcome to Padhaibook classes. We are doing the Match Trick series, and in this series we are going to learn about the divisibility test of 11. In our previous lecture we learned about the divisibility test of 2, 4, 8 and 16. I hope you guys understood that. If you didn't, you can watch that video again before watching this video. In this video we are going to only talk about the divisibility test of 11. Now let's take a look at the rule. What is the rule? As you can see on the screen, the rule states that the difference of sum of digits at odd and even places should be a multiple of 11. Now let us understand this rule. First of all, what do you mean by the digits at odd and even places? Now look at this number as an example. Now this is the first digit 7. Now this is the digit at odd place because it's the first digit. 5, as you can see, is the third digit in this number. 4 is the fifth digits. Now as you can see, 1, 3, 5, these are all the odd numbers and these are the places. We are interested in the place values. So when we say odd and even places, we mean the place values at odd and even positions. With that said, let's understand the rule. And similarly, the even places digits will be 6, 9, 2, 8 and 7 in this example. Now let's take a look at the rule. Again, we have to find the sum of the digits at odd and even places. Now we do that individually. We first find the sum of the digits at odd places. What do? We write odd. We say that odd is equals to 7 plus 5 plus 4 plus 3 plus 4 plus 9. Now let's calculate. What's the sum of the odd digits coming out to? 7 plus 5, 12, 16, 32. The sum of the odd places is coming out to be 32. Similarly, we can do this for even places as well. Now even places digits are in this number. We start from here, from 6. We take 6 plus 9 plus 2 plus 8 plus 7. What is this coming out to be? 32. Now as you can see, the sum of the digits at odd places is equal to the sum of the digits at even places, and which in this example is 32. Now we are interested in the difference of these sum. Now for example, the sum at odd places is 32 and the sum at even places is 32. Now what do? We find the difference. The difference is 32 minus 32. What do we get? 0. Now the difference is the important term here and it is the deciding factor. What do we get the difference? We get 0. Now 0 is a multiple of 11 because when we say 11 multiplied by 0, we get 0. Therefore, this whole number will be divisible by 11. You can verify that on your own. Right? Now let's take another example. As you can see, there is an example 2 on the screen. You can see the question and we'll do the same thing. We'll find the sum of the digits at odd places and then we will find the sum of the digits at even places. And as you can see, the sum of the odd places digits is coming out to be 22 and the sum of the digits at even places coming out to be 25. Now what is more important to us is we are interested in the difference between the sum of the digits at even places and odd places. So what do is we subtract 22 from 25. Now it does not matter if you minus subtract 22 from 25 or 25 from 22 because we are only interested in the absolute value. So don't care about that ki if the sum of the digits at even places is more or less than the digits of, so it does not matter to us. Now as you can see, you are getting 3. Some student might do it 22 minus 25. So what they might be getting the answer as minus 3. What you can do is you can find the absolute value of minus 3. So it will not matter. What matters is this number 3. Now 3. Now is 3 divisible by 11? It will leave a remainder. So it is not divisible by, exactly divisible by 11. Hence this whole number will not be divisible by 11. And you can verify this on your own. You do that, definitely. Let's take another example, which is an interesting twist on the same technique that we have learnt here. Let me just erase this for clarity purposes. Now let's take another example, which is a simple twist on the same concept that we have learned here. Take your focus on the example 3. It says that what should be the value of a so that the given number is divisible by 11. It should be 11 here. Now when it says that the value of a, it means the digit. Now a is a digit here. Keep in mind that it is not a complete number that is absent over here. It is a single digit number only. It cannot be more than one digit as well. If you guys are getting confused or something like that. Now with that said, we'll apply the same rule. We will take the digits at the odd places. Let's take the digits at odd places. 1 plus 4 plus 3 plus 8 plus 4. Now this is the sum of the digits at the odd places. What is it coming out to be? You can verify 1, 4, 3, 8 and 4. The digits at the sum places is coming out to be 20, right? Now let's do this for even as well. What's the sum coming out for even? The first even digit is 0, second is 9, the next is a, and the next is 7, and the next digit is 3. What is the sum that we are getting? We are getting a plus 19, right? All right. Now look at the rule again. The rule states that the sum of the difference of the sum of digits at odd and even plus should be a multiple of 11. Now odd is 20. Now take a look at here. Odd is 20 and even is something plus 19. Yani it means we get 19 plus a. That is your condition that you need for even. Now what should I add to 19 so that the given number is divisible by 11? Suppose the value of a is 1 here. Let's say the digit a value is 1. So what do we get? The even sum of the digits at even term become 20. Hence the missing digit is 1. We can do this by simply by hit and trial. It does not need some extra mathematical knowledge. The hit and trial method works to find the value of a most of the time. I guess this is the rule for the divisibility by 11. I hope you guys understood it. If you didn't, then you can comment below the video. Do subscribe and share. Thank you.